Okay, now, most of this is notes. You have 4 problems at the end of the video you're going to do on your own. Now, here's my first thing. You have an XY table. It says X, 0, 1, 2, 3, 4, 5. And that's all these tables are. But look at the Y. It goes from $5 to $15 to $25 to $35 to $45 to $55. Tell whether or not the data represents a linear relationship. So you start at the end of the problem, okay? And that's me drawing an arrow. And you want a minus. You want to take 55 minus 45. So that's 10, okay? Just put 10. Now, go from 45 to 35. Take 45 minus 35. God, shut up. Is 10. Okay. 35 minus 25 is 10. 10. It's 10 all the way through, so yes, it is a linear relationship. Okay, then, next problem. So again, start there, and you take 25 minus 40. Negative 15. It can be negative, that's fine. Now, 40 minus 55. Negative 15. So far it's looking good. 55 minus 70. Negative 15. 70 minus 85. Negative 15. And 85 minus 100, you guessed it, negative 15. So yes, it's linear. Okay, now let's look at on the next one. You want to start at the end. 607.75 minus 578.81. 29.84. 28.94. 94.94. That's a 28.94. Okay, then 578.81 minus 551.25. 27.76. So I can stop what I'm doing, and this is a no because it's not the same throughout the table. Okay, my next problem. 72 minus 74, negative 2. 74 minus 76, negative 2. 76 minus 78, negative 2. And you guessed it, negative 2 there. So that's yes. And you can kind of tell by looking at it if it goes by the same thing every time. That means it changes by the same amount every time. The way to figure that out is by subtraction. Okay, 53.75 minus 53.25. 0.5. Okay, then 53.25 minus 52.75, 0.5. Then 52.75 minus 51.25. That's 1.5, so that's a no, okay? Okay, next. Start at the bottom number and then subtract the number above it. Okay, so that's negative 8.14. It can be negative, that's fine. Okay. 162.90 minus 171.48. Negative 8 so right away that's different, so that is a no. Okay, that's pretty easy. Okay, if the rate of change is constant, then it's a linear equation. Now let's go take a look at the other. You don't need a calculator for this right here. It says tell whether the equation would be linear or exponential. Okay, we're used to doing linear. Don't write this down. This next thing, don't write down. Linear equations is to solve them on story problems. That's when I'd draw the box, the three boxes, you'd have the line, hence it's linear. But now we're going to come across a different type of problem, but the first step is to be able to recognize it. So the town has 7,000 people. Each year, 200 more people will move in. The time unit is always X, and then the other unit's Y. So you want to go per, and that's going to be people on top, years on bottom. So people per year. Remember, each and per mean the same thing. So if it says each year 200 more people move in, so people per year is 200. So that would be a linear relationship. Linear is the answer. Okay, a product is worth $500. Each year it decreases in value by 14%. Okay, so X and Y. So per would be per year. It'd be dollars per year. Now it says each year it's 14%. Well, 14% is not the same as $14. Okay. If something changes by a percent, it's not a constant, so that would not be linear. That would be exponential, okay? If you don't know how to spell it, it's up here, exponential. You'll see why it's called exponential when we solve a problem like it, okay? Because 14% isn't the same as $14. Dollars and percents are different animals. I am bench pressing 300 pounds. Each week I want to increase my bench press by 5 pounds. Okay, so per pounds per week. X is the weeks, Y is the pounds. Okay, read the sentence where it says each week. Per and each mean the same thing. So it says 5, so 5 pounds. It's not by percent, it's actual pounds, so that's linear. Okay, next problem. There are 30,000 people in a school. Each year the population decreases by 2%. So again, this is your X and this is your Y. Okay? So per year, and it's people. So each year the population, it says 2%. It doesn't say 2 people, so that's not linear. That's exponential. Okay, per. I underlined the wrong thing. Okay, I underlined the wrong thing. Okay, years should be underlined, not students. So X is years, Y is people. So it's per year, and it's people per year. Each year, 30 more students join the school. 30 students is like 30 people, okay? Same thing. So it's actual people, so therefore that's linear. Every year you keep adding 30 and adding 30 and adding 30. Here I would not be doing 2 every year, though, okay? There are 60 students out for football. The coaches want to increase that amount by 4% each year. So, year and students. So it's per year and students above it. Remember each and per. If you don't see per, find the word each. Well, what number? It's 4%. So again, that's not the same as 4 students, okay? So that's exponential. Okay, number 1, a pool has 600 gallons of water. The pool's drained at a rate of 8 gallons per minute. So per. And okay, so first off, this X and Y. It's per minute in gallons per minute. If you don't see the word per, oh, I do see per. So 8. 8 what? 8 gallons. So since that's actual gallons, that's a linear relationship. Okay, I would set it up the same way. We don't know how to do the exponential ones yet. Okay, a bank account's worth $600. It increases in value by 4% each year. Find its value after 10 years. So, per year, and then money on top. Okay. And if you don't see per, find the word each. There's each. So in that sentence with the each, it says 4%. Well, 4% isn't the same as $4, so that's exponential. Number 3, an internet company charges $300 for installation and $30 per month of use. Okay, so per, the time is your X, and then the other unit's the Y, so it's per month, dollars per month. Now, if you see the word per, and what number's kind of in the vicinity? Well, it's 30. It's $30. So since that's actual dollars, that's a linear relationship. Okay, number 4. An automobile is worth $18,500 when it is purchased. It decreases in value by 12% each year. Okay, so that's your X, that's your Y, so per year in dollars. So what's happening per year? So you don't see per, so each means the same thing. What's happening? It decreases in value but not by $12, though, 12%. So that is an exponential relationship. Okay, number 5, a plane is flying at 60,000 feet. On its landing, it travels 200 feet every second. So per. That's X, that's Y. So feet per second. Now another thing I'm going to throw at you, you don't see per, you don't even see each, but every means, per, each, and every all mean the same thing. So here's every, it's 20, what's happening every second? Well, 200 feet. Okay, and that's actual feet to match this, so that's linear. Okay, number 6, a town's population has 6,000 people each year. Population increases by 10%, okay? So per year. And people goes on top. Okay, so I don't see the word per, so I look for the word each. If I don't see each, I'll look for every. There's each. Each year, what's happening? 10%. That's not the same as 10 people, actual people, though. So that is exponential. Okay, now let's go to our third item. I forgot to do something on this. You need to help me out here, okay? Please put X beneath years and Y above that on the next problem. Whoops, never mind, scratch that.